Hello everyone, welcome to my channel. So in this tutorial we'll see one of the most well-known machine learning classification algorithm, which is known as support vector machine. The support vector machine were initially developed in 1960s and then they were found again in 1990s, and only now they have become very popular in machine learning because they are demonstrating such a powerful mechanisms from any other machine learning algorithms. But for now, let us understand how actually this support vector machine work. And also we are going to see how we are going to implement this particular algorithm for the given case study, right? So before I proceed further with the implementation, let me give you a gist on how exactly the support vector machine is going to work, right? Let me show you a figure here. You can see that here we got 2 points on a two-dimensional space, that is x1 and x2, and we got some observations which are in red color and green color. So now the question is how actually we try to derive a line that is going to separate them, because this decision boundary is so important when we start adding a new point. So that's the point of our classification, right? So whenever we try to give a new point somewhere here, so we have to categorize it whether it belongs to this category or other category. So it has to classify properly, right? So we want to create a decision boundary between these two, so that when in the future if we add some new points, we want to classify and know where they will actually fall, whether it in a green area or in the red area, right? So there are few approaches which we are going to apply here. The one way is to draw a vertical line, right? So which can easily try to classify which group it belongs to, right? Whatever is towards the left, it belongs to the red class or it belongs to the green class. Or there are, however, there is another way where we can draw some horizontal line like that, or we can draw some diagonal line somewhat like this, right? And so on, to separate the points to two classes. But at the same time, the all in this future, right, will have different consequences. So when we are going to add some new points, depending on where that points will fall, it will be added to the classes of green zone or red zone. So we want to find a optimal line, and that's what support vector machine does. It is all about finding the best line or the best decision boundary which will help us to separate our space into two classes, right? So now let's try to find out how SVM actually searches for this line. As you can see here, the line is searched through the maximum margins. Through the maximum margin. So here you can see a line, and this is a line in SVM to draw, and so basically it's a line that separates these two classes of points, right? And at the same time it has the maximum margin, which means this line is drawn equidistant. You can see this line, it is drawn equidistant, okay, from this red point to this green point, right? And the max margin means sum of these two margins has to be maximized in order to make this line the result of the SVM. Okay, now these 2 points are actually called as a support vectors. You can see this red point and this green point are called as the support vectors, because these 2 points are supporting this whole algorithm. Even if we get rid of all the rest of these points, nothing is going to get changed and the algorithm will be exactly the same, right? So these points are not going to contribute anything to the algorithm, and only these 2 points, okay, are going to contribute to the algorithm. That's the reason we call it as a supporting points or supporting vectors. Now what left? I think yeah, we can see that we have maximum margin hyperplane. Why do we call it as hyperplane? Because we are working in a 2D dimensional space, right? If it is in a 2-dimensional space, it is called as a hyperplane. So it is also called it as a maximum margin hyperplane. And then you get some green dotted lines and red dotted lines. Okay, wherein the green dotted line is called as a positive hyperplane, and the red one is also called as the negative hyperplane. So this will decide that whenever any new data point is been added, based on the maximum margin hyperplane, it is going to decide whether the points are nearby to the negative hyperplane or to the positive hyperplane. Okay, if any points belong to the green points, all the red points will be negative hyperplane. Okay, if that any point belongs to the red class or the red category, all the green points becomes the negative hyperplane for this. Okay, so in the red category, green points are the negative hyperplane. For in the green category, red points are the negative hyperplane. Okay, that's the reason we had drawn this diagram. Now, without wasting much time, we'll directly see how to implement support vector machine and apply this for a given case study. We have taken the same case study as usual. We have taken it for logistic regression and also for k nearest neighbor and decision trees. The same case study been taken, and the data set what we are going to use it for the study is social network ads. Okay, wherein we have three main variables here. Three variables are there, as you can see: age, estimated salary, and the purchased one. Okay, wherein the age and estimated salary will be considered as the independent variable vectors or matrix of features, and the last one, purchased, will be the dependent variable vector. The main aim of this study is to predict whether a given a person with the given age and the estimated salary is going to purchase a new car from the same company or not. Okay, for the same case study we had applied multiple algorithm. Already we had seen in my earlier lecture that for after applying the logistic regression and KNN and decision tree, what is the accuracy we had received from the model. Now let us try a well-known algorithm called SVM for the same case study. As we all know that we have to import the required libraries like NumPy and Pandas. So we'll import it now, and we can see that it has imported successfully. Now it's time to import the data set, right? As I already mentioned you that I am using social network ads.csv file as my data set, and through the Pandas library I'm going to invoke a method called read_csv to read the CSV file. And once I successfully import it, you can see in a variable explorer the data frame called as dataset, right, wherein you can see all the data have been popped up based on the age, estimated salary, and the purchased column. Now you can see that all the independent and dependent variable vectors all are in the same data frame. Now it's time to split up this data. Okay, so what we do means we will try to locate the index position of this data set. As we can see in the data set, the first position, this age and estimated salary will contribute to the independent variable vectors, and the purchased for the dependent variable vector. So purchased will act as the outcome, and age and estimated salary will be the input to our models. Okay, so we have to locate the indices like all the rows and all the columns except the last columns, fetch all the values and store it in a variable called x. Also we take all the rows and only the last column and store it in a variable y. This is how we can easily split the data into matrix of features x and dependent variable vector y. Right, now later on we'll try to split the data set into training and testing. So for that sake we have to import one class called train test split from the library model selection. Okay, we are importing a very famous library called scikit-learn.model selection, from which we are going to import a class called train_test_split. Later on we have to create an object of it by creating an instance of that class. So we will try to create an instance of the class here, train test split, and we pass few parameters, and you can see the parameters are x, matrix of features, and dependent variable vector y. Okay, and we had given the test size as 25%. So out of 400 100 data we are going to keep it to test, and the random state is 0, so that we get the same result every time we execute this, right? And we will do this and execute. Okay, after we split the data, we get two pairs of data here for train and testing: x train, y train, x test, and y test. And we can see it in the variable explorer that all these 4 variables have been successfully uploaded. And you can see in the x train, among the 400, only the 300 data have been fetched, right? And in the x test, we have only 100 data set. Similarly, in the y train and y test, we have only the 100 data, but only one column, that's the dependent variable vector purchased column, right? Now it is very clear from these data that the data are not in a right scale, because we can see few data are in the range of 40s, 30s, 50s, and 20s. Also, it is same in the case of estimated salaries. So to avoid misinterpretation in the model, we have to do the feature scaling mechanism. And as I already mentioned, that there are two types of feature scaling, one is normalization and standardization. So in this case study, we are going to apply standardization method, right? And we are going to import that class from the library pre-processing, okay, and create an instance of the class and store it in an object. Via that object, you can fit and transform the feature scaling approach to the trained data set, that is x train, and you can transform for the test data set and store it in a two different variable, x train and x test. So this should be the same name as that of the variables which you had utilized to train and split the data set. Okay, so you can execute this code, and you can see, let us try it out in a training set. You can see all the values are within the range of -3 to +3, even in the same in the case of estimated salary. Let me check for x test also. Yes, it has already updated successfully. This comes only when you fit and transform it, right? Now it's time to build a new model called as SVM. Now, as you know that the decision tree classes, we had imported it from tree library, okay, sklearn.tree. Similarly for knn sklearn.neighbors, but for support vector machine, we are going to import it from SVM itself, but we are going to import a class called svc here, okay, right? So this svc class will allow us to build the kernel SVM models, okay, within either you can even draw the linear kernels or non-linear kernels. Okay, let us see first with the classic SVM model. We will apply the linear kernel for the first time, and let us understand and estimate the results. After that, we can apply the non-linear kernels for the same model, and we can distinguish the results among these two. Okay, so first of all, we are going to apply the linear kernel here. That's the reason while creating an instance of the class, we are assigning the kernel is equal to linear model. Linear model means, I hope you understand, that it's going to draw a linear line, a straight line, and it tries to divide or to classify the two classes properly. Okay, so I hope you understand that whenever it is a linear line, the accuracy won't be too high, because you see that if the data are distributed and if the data are non-linear, then it is very difficult whenever you apply a linear kernel for this model. That's the reason I told you that we are going to apply kernel support vector machine, kernel SVMs also, so that we can try it with the another non-linear kernel function called as radial basis function, and we can also test it for this. Okay, so before that, let me try it out with the linear kernel function. We have kernel is equal to linear, and also we had applied the second parameter random state equal to 0, so that we can get the same result every time we execute it. And finally, we fit the model to the trained data set, that is x train and y train. After writing this within 3 lines of code, we had successfully implemented the model, and the model is ready. Now let us try to predict few values based on the data set. So I taken the same value here. Okay, we have to from the object what we have created for the model, from that you have to import invoke a method called predict and pass a parameter of the values for the age and estimated salary in a transformed way and try to predict the output. So it is telling the person is not going to purchase a car of age 30 and with the salary 87,000. Let us try to give some other values. Okay, we can see the okay, most of the values are 0. Very few people are eager to purchase this. Okay, as for I think we can see in the age 46, 48, 45, 45 to 50 with this estimated salary the chances are more. Let us try it with 1. I'll give the 46 with the 29,000. Let us predict the output. Okay, 46 with the 29,000. Let us see whether we are going to get a right output or not. Okay, 46 with 29,000, the chances are very less. Okay, let us try to predict with some other values. What about 46 with the 49,000? Okay, so it is very clear from the output that the outcome is not really based on a single variable vector, but really on the multiple variable vectors. Okay, anyways, it is giving the person is not going to purchase even though the salary is bit high comparatively to that. Okay, we can still try on with some different values. You can try that, right, when you practice it. However, we'll let us now try to predict all the values which are there in the test data set. Okay, and we had used since it is we can't display it in a graph because the data are not in two-dimensional, so we have to concatenate all the results one by one based on the prediction and the test. Okay, and you can see that we had used for the prediction dot reshape. That means the way in which we would like to display the results, and here 1 represents vertical and 0 represents horizontal. So we pass actually 3 parameters, one for the prediction. Okay, first parameter, second parameter is for the tested, right? So wherein you what happens here is the first output whatever you get is a predicted output. Besides that, you would like to have another output. Okay, not in horizontal, in a vertical way. That's the reason we had put 1 here. I hope you understand. One after the another, right? Vertical way you want it. One below the other becomes horizontal. Okay, so I want first the predicted output. Besides that, I want one test output. Now once one set is over, second set should be under that. So we are giving another one here. This is for horizontal. This is the third parameter I'm telling you. Okay, for if you use this one within this reshape function, it is 1 means vertical, 0 means horizontal. So outside the, see, after comma if I give it, okay, after comma, in the sense I am coming totally out of this parameter, then this one becomes horizontal, means one below the other. You are going to see all the results of the test data set. Let us understand it by seeing it, the output of it. Okay, so we are going to concatenate all the results in a single picture. So let us execute this and analyze out. This is how it comes. So this is the prediction, this is the test one, so horizontal, vertical, and after one record this is the second record, so this is horizontal. Okay, I hope you understood this. So you can see most of the results are same, the 1 1, okay, 0 0. However, any model will not give you 100% accuracy. There will be some few wrong predictions also. You can see it here. Okay, instead of seeing one by one, we can also try to evaluate the performance of the model by applying few classes like confusion matrix and accuracy score. Okay, we'll try to import these two classes from matrix library, accuracy score and confusion matrix, and finally we are going to create an instance of the class by providing these two parameters, testing and prediction, and let us try to print the value. So this confusion matrix will give us an insight on how many right and how many wrong predictions been done. Okay, now as per the result, it's telling 66 plus 24 right predictions, so total 90, and 2 plus 10 wrong predictions have been made. So due to which we can easily estimate the accuracy of the model, that is 90%. Okay, and we can see 0.9, 90% accuracy we are going to get it, right? So which is comparatively less than the KNN. Okay, but anyways, we can try to since I told you already that we are using the linear support vector machine model. Okay, linear will, there is a biggest disadvantage in linear, it draws always a straight line. So if the data are distributed, for example, if I show you the data in this way, look at the data here. If the data are totally non-linearly separable, okay, this is the linear data, we can easily try to classify the data if we draw a linear line here. But what if the data are in this way? It is very difficult, because even if you draw the line anywhere diagonal here or horizontal or vertical line, so you are not able to separate all the classes effectively. So that's the case where we apply a non-linear SVM model. Okay, and the non-linear SVM model, we are going to use a radial basis function as the parameter. So in place of this kernel equal to linear, let me put RBF, radial basis function. Okay, and try the model again. So we have to compile this model again. You can see as of now we got 90% result. After we put non-linear model, let us try to predict the output. Okay, let me execute all at once and let us see the output. Yes, we got 93% result. That means 3% better results comparatively to the linear model. This is how support vector machine is going to work. That is why this algorithm is called as a well-known machine learning classification algorithm, because it uses some powerful mechanisms to classify the data based on the hyperplanes. Okay, maximum margin hyperplanes. Based on this maximum margin hyperplanes, it is going to select which hyperplane will be the optimal line. Okay, so first of all it tries with the vertical, horizontal, diagonal, and in different ways. You can see, as I already shown you in the picture here, in a different way it tries, and finally which will be the best optimal line, it will select on its own based on the data distribution, and finally it tries to classify the data, and it will ensure that there is a equidistant between the two classes here. So you can see the red point here and here. So it will ensure that the corner red points which is very closer to this maximum margin, it will keep the equidistance from that by using some distance formulas. Okay, that is why it is known as a popular algorithm in machine learning. Anyways, thank you for watching this video, and happy learning.